Welcome back to College Algebra. Today we're going to be looking at section 2.6, other types of equations. This section is just going to be a Mod Podge of a bunch of different types of equations that we can solve using different tools. A lot of these tools we'll already have the skills for. We'll just have to find out how to apply those skills. So let's jump right in. Our scripture for today. We're doing a bunch of different types of equations. Sometimes college algebra is just college algebra. And so this is a good scripture to be reminded of. John 1:12 says, "But to all who did receive him, who believed in his name, he gave the right to become children of God." And this is what we believe as Christians doing science and math, is that we identify first as Christian, and then as mathematician, we are first children of God. And then we can learn about the world that God's made. In the same way a child would learn about the things that his father has prepared for him or his mother has prepared for him, or learn about his home and his world in his family. That's what we're doing when we explore math, is we're taking our place as the children of God, exploring the world that God's blessed us with. So, with that being said, let's jump into some exploration. The first type we're going to look at is rational exponents, which you may have seen before. You may not have, and it might feel a little scary, and that's okay. So we are going to look at this first equation. Actually, let's look at this long string of things where your exponent is a fraction. So up in your exponent, you have a fraction. The top of the fraction tells you to do exactly what top's always told you to do, which is raise it to that power. The bottom of the fraction tells you to root it by that power. So you might have the square root, which would be a 2 on the bottom, or the cube root, which is a 3 on the bottom. But rational exponents tell you to execute the top and the bottom separately in whatever order you find best or you find fitting. So we'll start with 64 to the negative 1/3, and we'll review a lot of exponent rules. The first exponent rule would be x to the negative 1 is exactly the same thing as 1 over x. So a negative in your exponent just flips it on itself. And so 64 to the 1/3 is exactly the same thing as 1 over 64 to the 1/3, where that negative went away and we moved it to the bottom. A negative exponent just means you're allowed to move it to the other side. Now we need to figure out, well, what does 1/3 actually mean? Well, actually, it means the cube root of, that's what I was saying about the bottom tells you what root you're doing, which basically means the question, what times what times what equals 64. And by process of elimination, starting at 1 and working up, you can say 1 times 1 times 1 is 1, so that's not it. 2 times 2 times 2 is 8, so that's not it. 3 times 3 times 3 is 27. But here we get 4 times 4 times 4, where you get 1664. And so your answer to the cube root is that 4. And so your entire equation just turns into 1 over 4. That's not even an equation. That's just reducing fractional exponents and a little reminder on how to do that. All right. What about when it becomes an equation? How do we solve for x when we have a fractional exponent? Well, we take the equation, and much like we do with any other equation, we draw a line down the middle, and we say what we do to one side, we're going to have to do to the other side. And so what I'm going to do is I'm going to take this fractional exponent, and I'm going to raise it by the reciprocal fraction. And what I do to one side, I have to do to the other. So that blue step was done to both sides. And now what we're left with on the left side, if we multiply exponents, we just get x to the 6 over 6. Notice 3 times 2 is 6. And 2 times 3 is 6 on the bottom. And I'm not going to evaluate this yet. I'll wait and do it in a second. And then, well, that's just x to the first power, which is just x. X to the first power, that's just x by itself. And now we have to decide, okay, well, what is 125 raised to the 2/3? There's 2 ways you can do this. One is much easier than the other. The first way you can do this is you can square 125. So you could take care of the square first. But 125 times 125 is a pretty big equation. And so I'm going to start with the 1/3, or the cube root. And so I'm going to rewrite this to start as 125 cube rooted all squared. And what times what times what equals 125? Well, that's just 5 times 5 times 5. So we got 5 squared, which is just 25. So now, since we're working with equations, we have a solution set, which is 25. If you raise 25 to the 3 halves, you get 125. This same thing is true with the next one. It's just going to have one extra step of moving the 5 over. I'll leave you to do that in the try it because the steps are going to be very similar. So try this on your own. If you need help, you can look at the completed notes. You could look through the textbook. You could email your instructor. As you work on your homework, you'll see there's some video links that you could work on there. So I'll leave that for you to try as we move to the next type. The next type is a polynomial. And a polynomial equation is going to be tempting because you're going to want to feel like you could divide by x2 and divide by x2 and cancel some things. But what you actually do if you do that to start is you lose some of your possible equations, solutions. Like, for example, if we plug in 0, we get 0 on both sides, and that's true, but we would lose that solution. So the way we solve these is much like we want to get an equation like we've seen in almost every section before. We just want to move that 3x over, and so we're just left with a 0 on the right side. And now if you remember grouping from the quadratic equation section, we're not going to group, but we're going to use the same skill which we did, which is factor something out, or reverse distribute, like the distributive property but backwards. And we're going to take out whatever's in common. And so a 3x squared is actually all going to be in common here. And we're going to be left with, on the outside, a 3x squared. And on the inside, we're going to be left with 12 divided by 3 is 4. x4 divided by x2 is x squared minus 1. And now we have the zero product property showing up again where we can set each side equal to 0. And so I'll set 3x squared equal to 0 and solve that. So x squared equals 0 because divided by 3. So x equals the square root of 0, which is just 0. There's one of my solutions. And then I'll take the other side and do the same thing. 4x minus 1 squared equals 0, which means 4x squared equals positive 1 because we're moving it to the other side, which means x squared equals 1 over 4, which means x is equal to the square root of 1 over 4. And we are going to have to reduce that. So we're going to have to ask ourselves, we introduced a square root, so we need to add a plus or a minus. Because I don't know which one they meant. They could have meant the positive version or the negative version. Both of those squared will result in a positive number. And we're asking ourselves, what times what equals 1/4? If you know the answer already, you could jump straight to the answer. But if you don't know the answer, what we could do is we could split up this root to the top and the bottom, and we could see that we have plus or minus 1 over 2. And so we have 3 total answers in our solution set here. We have the negative 1/2, the 0, and the 1/2 all working together. And if you plug and chug any of those numbers back in for x, you'll get a proper solution or an equivalent expression. 2 things on both sides that are the same. That's one type of equation, polynomial equations. So we've done fraction exponents or rational exponents up at the top. Then we did polynomial equations where we set them equal to 0 and solve. Now we're going to do radical equations where we have a square root hiding in our problem from the very, very start. Now it's worth noting here that plus or minus rule. Because the problem has introduced the square root, or somebody typed it on the Word document, or somebody put it in the textbook, they chose plus for you. You don't need to worry about introducing a plus or a minus when you solve that square root. They picked plus. When you introduce a square root for the first time, you undid a square, and so you are responsible for factoring in both solutions to that equation. But when the problem provides you with it, they've picked plus for you. So what we're going to do is we're going to square both sides to get started, to get rid of that square root. X plus 3 equals 3x minus 1 squared. Notice one of the biggest mistakes ever that I see students make is try to distribute that square. It does not distribute. Exponents don't distribute across addition or subtraction, only multiplication. If it was multiplied by 2, then we could distribute it. But as it stands now, this is the same thing as 3x minus 1 times 3x minus 1, and so we are going to have to FOIL. I might rush through the FOIL for you. If you want to slow it down and try it on your own, you should, but I'm going to go ahead and FOIL that to 9x squared minus 6x plus 1. Where the first terms resulted in 9x, the second terms resulted in negative 3x and negative 3x combining to be a negative 6x, and the last term's negative 1 times negative 1 was a positive 1. Now, just like the polynomial equation, we're going to move all the terms to one side, and so I'll subtract x and I'll subtract 3 from both sides. Make sure you subtract them from their proper terms, and we'll get 0 is equal to 9x squared minus 7x minus 2. And this is an equation where grouping is going to be necessary. We're not going to be able to just factor it straight up. And so because grouping is necessary, we do a times c, which is 18, negative 18, careful, that negative 2 for the c value. Remember, this is 9 times negative 2. And so negative 18 is going to break apart into negative 9 and 2 to add up to give you 7. And so what we're going to do, back from the grouping, if you need to go back and watch quadratic equations to practice grouping, that's okay. Take a pause, read through the textbook, and work it on your own. We're going to break that 7x squared up, and we're going to say 9x squared, and 7x is going to be broken into minus 9x plus 2x. We got the 9 and the 2 from over there. Minus 2. And then we're going to factor out similar terms in each of the groups. So I'm going to say, what's in common in the first group? A negative 9, or positive 9, and an x. They both have a 9 and they both have an x. And if we take that away, we'll be left with just 1x minus 1. And then what's in common in the second group? If we take it out, it just looks like a 2. There's no x in common anymore, so just a 2, and we'll be left with x minus 1. And here you'll see your terms match, your grouping terms matched. That x minus 1 matches that x minus 1. And so we'll do one more reverse distributive property where we factor out an x minus 1 to the very front. And we're left with 0 equals 9x plus 2 times x minus 1. And we have factored our term. I'm out of room here, so I'm going to go off to the side a little bit. And I'm going to set each of those equal to 0 and solve. And so the left-hand side one is going to result in x is equal to negative 2 over 9. And the right-hand side one is x is equal to 1. How did we get those? We set them equal to 0 and we solved. We're just spending a little less time doing it because we've done it in the past 2 videos and the notes and the homework. And hopefully you're getting pretty good at solving these things by now. But we need to take a pause. And I'm going to look at these instructions even though we don't always read them in every video. And we need to confirm our solutions by substituting them in. Before I highlight them or put them in a solution set, I need to check. This is one of the first types of problems where we've said you have to check because square roots introduce something into the problem where the inside of the square root cannot be negative. And so we need to check and make sure this is true to make sure that our solution is actually results in a true statement. So the first thing I'm going to check, I'm going to use the original equation and I'm just going to plug my numbers in. And so I'll check negative 2 over 9. This one's going to be a little tedious because of fractions. So the square root of negative 2 over 9 plus 3 is equal to 3 times negative 2 over 9 minus 1. And so 3 plus 2 over 9 is going to be negative 2 over 9. I'm going to rewrite that 3 and do this in 2 steps so you can see it happen. 3 is the same thing as 27 over 9, multiplied by 9 on the top and the bottom. And we get 25 over 9. And if we square root the top and the bottom, we get 5 over 3. Remember, we're leaving that as a positive square root because it came with the problem. The problem introduced this as a plus square root, so we're leaving it alone. And we're going to see, does that equal the other side? 3 times negative 2 is negative 6 over 9. Minus 1. Here we're going to do the same trick where we say negative 6 over 9 minus 1 would be minus 9 over 9, because that's another way you can write 1. And negative 6 minus 9 is negative 15 over 9. So wow, it looks pretty close actually. If you reduce the top and the bottom, you could say that this would be 5/3 equals, divide by 5 on the top, you get negative 5. Divide by 3 on the top, you get negative 5. Divide by 3 on the bottom, you get 3. And actually, this is not true. 5/3 does not equal negative 5/3. And so what we're going to say is this is not a solution to the equation. We'll check our other one, though, just to be safe. I'm going to run out of room, so I might check it over here. If you're following along, I'm checking x equals 1 as one of our solutions. This one's going to be a little easier to plug and chug. Remember, we're taking this original equation as our check. So root 1 plus 3 equals 3 times 1 minus 1. So root 4 equals 3 minus 1. 2 equals 2. It worked. So we did have to check both terms and see that one of them wasn't actually a true solution. And our solution set is just going to be that x equals 1. That we got up here. We got from this factor right here. All of those terms working together. That might be a little tedious. You might want to pause it, rewind it, make sure you understand each step. We had a lot of stuff going on there. We had factoring by grouping happening. We had squaring both sides and foiling happening. We had checking solutions and combining fractions. And so if you need to pause and practice, that's an okay thing to do. Like I did before, I'm going to leave you to try this one at home. I will warn you, this one is a little bit challenging, but it's really good for you to work on. This is a challenging problem because you're going to have to FOIL probably twice. Both of those square roots make me feel like you're going to have to FOIL twice. And so as you work through this problem, I would encourage you to stick with it, try it. If you want to go to the worked out solutions online and work with them, that's okay. It's an okay thing to do. Yeah, so I'll leave you to that problem as we work through the rest of these other types of equations. So we've just learned a bunch of different types. We've learned rational exponents, polynomial equations, square root equations, but we haven't learned any new skills. These are all skills that we've had from other sections. It's just that equations that they're getting applied to may look a little different. This might be the first rule that we learn. And that's when you see this absolute value sign inside of an equation. So the first thing we're going to do is we're going to get that absolute value by itself using the rules from what you do to one side, you have to do to the other. And so we're just going to get 1 minus 4x is equal to subtract 8 from both sides, and you get 5. And then once you get that absolute value by itself, we're going to split it into two completely separate problems. One of them is going to look exactly the way it looks. This would be the positive case. This would be when the inside of the absolute value results in a positive number, nothing changes. But when the inside of the absolute value results in a negative number, we flip the sign of the other side. So I flipped that 5 sign. This would be positive case, and this would be where the negative happens, where you have to flip the sign. But other than that, it's exactly like the problems we solved before. You just go and solve each side. So negative 4x equals, if we subtract 1 from both sides, we get 4. And so x equals negative 1 is one of our solutions. And then over here, we get negative 4x. If we subtract 1 to both sides again, we get negative 6. And so we get x equals negative 6 over negative 4, which if we reduce as a fraction is just 3 over 2. And so our solution set is negative 1 and 3 over 2. Absolute value equations. A different type of equation. The title of this section says it all. The title of this section in your textbook is Other Types of Equations, and it might feel like we're just throwing a lot of different equations in one section and saying, hey, you might see these at some point. Be on the lookout. All right, the last other type of equation is going to be, it looks like a quadratic. It's in the form of a quadratic, but it's not quite there. And so, for example, this looks a whole lot like what we're used to seeing with the quadratics, but it's not quite there. The reason it's not quite there is we have that 4 in the first term, the 4 in the exponent of the first term, and a 2 in the exponent of the second term. And so what we're going to do is a little sneaky manipulation, and we're going to write x squared squared. Because x squared squared is x to the 4th power. Minus 8, and this is not necessary, but I'm going to put a parentheses around it so you can see where those two things match. Minus 9 equals 0. And then I'm going to say, man, wouldn't it be awesome if those weren't x's or x squareds? Wouldn't it be awesome if those were just some variable on their own? And so off to the side, I am going to let them be just a different variable. A lot of times the book will pick u, called u substitution. Call it t, call it q, call it whatever variable you want to. But I'm going to say u is actually x squared for the rest of our problem. And so if we substitute u in for x squared, we get u squared minus 8u minus 9 equals 0. And now it looks just like a fraction or a factor that we can solve. And it's actually one of the easier versions of factoring we can solve. It's one where this will break down into a perfect b term. So negative 9 and 1 multiply to give you negative 9, and they add to give you negative 8, which is good. All right, and so we're going to break apart our fraction into u minus 9 and u plus 1 equals 0. That was factoring. If you need to review that, that would be in the section called quadratic equations, if you need to go practice factoring again. And so then we can solve these by setting each term equal to 0, where u minus 9 equals 0, which means u equals 9, and u plus 1 equals 0, so u equals negative 1. And usually we're done. But wait, we had one middle blue step there at the top where we said u is not u is actually equal to x squared. And so I'm going to bring that back in, and I'm going to say, wait, this was supposed to be x squared equals 9. And x squared equals negative 1. And so what we can do is square root both sides and get x is equal to plus or minus, because we're introducing a square root, plus or minus because we're introducing a square root. And there's our 4 answers instead of 2 this time. So we get x equals plus or minus 3 and x equals plus or minus. You might remember this from section 2.4, I think, the complex number section. The square root of negative 1 is just I. And so we have 4 solutions here to report. We have the solution set of plus or minus 3 and plus or minus I. Pause right there if you need to look at that for a second. That was u substitution. The next one's a little easier. I'll leave it for you to try. A lot of these were given two of each attempt. I'll go ahead and give you your u value, though, just so you can have something to start with. I'm going to say let u be x minus 5. It's a little easy to, or it might be possible to see if you look at that highlighted, how those parenthesis sets kind of match. If we turn those into u's, this is going to turn into a nice, easy factorization for us. All right, and then we have one more type of problem, which isn't necessarily a new one, but it's combining all of the sections we've done in all pretty much this whole year. And it's what happens when you have a rational equation that turns into a quadratic at some point. And so if you remember from rational equations, the first thing I suggested that you do is to factor everything just before you even start. And usually you'll see those factors match. That factor matches that factor, and this purple factor matches that purple factor. Makes your life nice and easy when everything matches. So I'm going to rewrite this equation as 3x plus 2 over x minus 2 plus 1 over x equals, I'm just going to write it using the factorized term. And kind of I just cut this middle term out for a little bit. It's the same thing. All 3 sides of the equal sign are the same thing. I just want to cut it out for a little bit so that we can see our LCD. So our LCD, or our term to multiply by, is just going to be that factorized term. And then we're going to multiply the both sides by that factorized term. And we're going to see what happens. A lot of stuff is probably going to break down for us. So here we go. If we distribute it across this side, we end up with 3x plus 2. And then the x minus 2's are actually going to cancel. And we're just going to end up with times x. If you want to see that happen, distribute the whole term. And watch those x minus 2's cancel. And then if we distribute it to the second term, we're going to see x times x minus 2 times 1 over x. The other term's going to cancel, the x term, and that plus sign stays the same. And then equals, here we see everything cancel except for the negative 2. And so we have an equation like the first day of class when we learned about equations that are one line, one variable, no fractions. We have 3x plus 2 times x plus, that 1 can kind of go away, plus x minus 2 equals negative 2. And we solve this the same way we solved our first day equations. I would like to note though, and we always said this, kind of when you get rid of a denominator, you really need to make a note and you need to say, hey, I had a denominator that I just got rid of and there's some conditions for x. From the original equation and from the second line of the equation, so if you look at both of these lines right here, x can't be 0 because that would result in a 0 on the denominator in the highlighted yellow sections. And x can't be 2 because that would result in a 0 in the denominator in the highlighted purple sections. And we don't have a denominator anymore, so I just need to make a note of that so when I get to my final answer, I can check and say, hey, these are domain restrictions. All right, let's solve this. I'm going to work through this maybe a little fast, and that's okay. First things first, distributive property. And we get 3x squared plus 2x plus x minus 2 equals negative 2. Next thing, I'm going to combine like terms, and I'm going to say we get 3x squared, the x's combined, plus 3x minus 2 equals negative 2. And then I'm going to add 2 to both sides. Plus 2. Plus 2, that's nice and neat. We're left with 3x squared plus 3x equals 0. I did forget to draw a line, but if you want to draw a line through the equal sign so you know what you're doing, that's okay. And now we have a factorization that we can do. Notice you might see something in common. Always suggested to factor out the thing that's in common, 3x. And if you factor out a 3x, you're left with x plus 1. Equals 0. And we're going to solve both of those by setting them equal to 0 with the zero product property. 3x equals 0 results in x equals 0, and x plus 1 equals 0 results in x equals negative 1. And if I zoom out and look at this whole problem, I had a note, a domain restriction from the denominator from the rational function. I said, hey, wait, x is not allowed to be 0. So because, I'll highlight it orange right here, x was not allowed to be 0, this solution is no longer valid. And we're left with only one valid solution of negative 1. And that is section 2.6, other types of equations. Again, if you have any questions, your instructor would be more than happy to reach out to you. I'm grateful that you watched this far to the end. These are all very different types of equations, and I would encourage you to practice them, to work through them, to pause the video if you need to, and work alongside me. Don't forget to look at the blank notes, the completed notes, my videos, the textbook, any resource you can to learn these types of things, even if it's to go to YouTube and Google, how do I solve this? It's a good idea for you to practice instead of just watching a video and assuming that you've got it mastered with one watch. Thank you for watching this far, and I'll see you next time.